exploration of space will go ahead, and it is one of the great adventures of all time.
So, as the objective of the Liftoff Africa suggests about establishing such Vyomika space labs on various scale in African continent, with this particular platform is really important, because whenever we talk about space education or space learning, you need to have a platform that support your ideas. People talk about space traveling, space tourism, colonizing Mars and Moon, going interstellar, interplanetary. But all this need a very solid foundation where new ideas can get welcome, and there should be people, space educators should facilitate and enable these ideas into some project-based learning. Now, this particular lab will do the same for the students who will be associated with this lab facility that we want to promote and we want to establish all over Africa. Now, talking specifically about this lab audience, this lab is crafted for students from 8-year-old to 18-year-old, and that covers class 4th student till class 10th or 12th students. Now, why we are targeting the young audience of schools? Because they are the brilliant, cosmic minds who have all the curiosity, all the amazing ideas and imagination about space. So we want to, get them on the right age. We want to develop and enhance their understanding towards space studies, and then we want to counsel them. We want to, guide them that how they can craft a career out of whatever they are learning at this particular platform. Talking specifically about the type of infrastructure we provide into this lab. So this lab include multiple space models. That is, the models which is very much popular on global scale. So talking about India, these are the 4 rockets which is really important for Indian space program. The PSLV, where with the rocket which took our first satellite to the planet Mars. Along with that, the first cryogenic equipped rocket. Then we have GSLV Mach 3 that took our second mission to the moon, and finally the upcoming mission of Gaganyaan, which will take the first Vyomnaut, the first human astronaut, yes, to the space. So and along with that, you have other models such as Starship, Space Shuttle. So these are dummy models like this. So just a glimpse from a particular exhibition that we provided. So these are typically 6 feet to 5 feet space rocket models and various spacecraft models that give the physical understanding of how these space missions work. Then also this particular lab infrastructure include multiple kits, which includes, for example, telescope of various aperture size, then hovercrafts, lot of flying aircraft, RC aircraft, drones, like basically get into the infrastructure of this lab. Then we also offer the rocketry satellite kits. So with our Vyomika training SAT kits, Vyomika standard SAT kit, like standard SAT kit satellites, the students get that practical exposure about designing the circuits, integrating the electronics, and building something which can deliver at the end some type of useful data to them. Then also flying rockets, and also talking about various rover missions. Then the students receive a lot of electronic sensors, microcontrollers, receivers, transmitter, flight control boards, motors. So they basically get into the do-it-yourself kit-based arrangement, project-based learning, experimental learning, so that they can not only just think about space, they can also develop projects, do research, real-time contribution in these space studies, which will definitely going to enhance their level of understanding and imagination toward these space-related subject areas. We also provide them various tools and equipment if they want to build something from scratch. They get these equipments to like mechanical, electrical, and measuring tools, which they use to develop these specific projects. Also, because making model rockets or dealing with these type of kits require safety and proper type of power supply. So we offer these things as well inside the lab. So this lab, as you can understand, hold the entire ecosystem for our student to do anything related to space, whatever they are not learning things out of books, but getting out of the equations and creating something useful, something wonderful. Now, you know that how important it is now, the role of rapid prototyping in the industry. So that's why we want to introduce 3D printing to our students as well. So we offer these 3D printing tools and equipments to our students in this Vyomika Space Lab, so that they make nose cones of rocket, they make structure of the cube satellite, they make arm of a drone or maybe arm of an aircraft. So they literally learn to software design, and then they take a print out of that particular design. Along with that, we offer them a lot of free space learning resources like workbooks, lesson plans, quizzes, tests, game puzzles. We inform them about the recent news and activities happening in the space industry. We suggest them YouTube videos, podcasts, which they can listen to and develop their understanding about space. Then also we hire a lot of space experts, and we provide them career counseling, because now, whenever we talk about education, even on school standards, we many times miss the counseling for career part, right? It is really important to tell the student that how they can make career out of whatever they are learning. If they are doing engineering, how they can grow engineering abilities into a well-established career for them. So all these things will be told to these people who will be the participant of Vyomika Space Lab. Now, we also understand you must be knowing about the meta universe, metaverse from Facebook. Now the Web 3.2.0 basically will allow a lot of people to get exposed with these VR headset. So virtual reality and animation based content will be an integrated part of education very soon. So we don't want to get left behind. That's why we are also exposing our students with a VR and AR and animation based space learning content, where they just wear that VR headset and boom, they are into the Martian environment, right? So these type of things we are providing under this lab facility. And the ultimate idea is to collaborate with certain national point of contacts who are active in introducing something like that for India, right? For their particular country. Now, talking about the subject domains that we majorly cover in Vyomika Space Academy, particularly in the lab. So whenever we talk about space curriculum or space study, it basically go into two directions. One, which will take you to become Albert Einstein, that is space science. Another, that will take you to become someone like Elon Musk, which is space technology. So whenever we talk about space sciences, so space sciences includes subject like solar system, galaxies, stars and its constellation, and origin of universe, existence of alien life, telescope observation, Big Bang theory, dark matter, dark energy, relativity theory, and quantum physics. All these theoretical aspects of space science, which majorly get covered under astronomy, astrophysics, and cosmology, comes under this particular area of study. And when we talk about space technology, so subjects like rocket science and tech, satellite technology, space robotics, which includes rovers and interplanetary exploration through using rovers, astronauts in space, deep space network that basically detect where the satellites are, where the aliens are, where the exoplanets are. Then like astrobiology kind of subject, which is very new, very less people are engaged, but there is a great scope in the area of astrobiology where you are studying exoplanets and the possibility of life on other planets, right? So this is really interesting. Then with the increasing number of astronauts going to space, one particular branch is also going up, which is space medicines, right? So the future space industry need doctors who can treat these astronauts before and after the flight. Then space tourism, it's booming up. You all know that what SpaceX, and basically Blue Origin and the Virgin Galactic have achieved in terms of space tourism. Then a lot of countries, including India, China, Russia, America, they are setting up various international space stations, into the orbit around the Earth. So that is one area where future engineers can give their research scope or engineering scope. And finally, the ultimate goal of settling on Mars and beyond, right? That is another area which is very much open for anybody who is dreaming to land on Mars someday and getting that Martian passport, and living as a citizen of Mars. So these areas are very much, subject areas are very much exposed to our students, and we truly believe with learning methodologies that we use in our labs, which includes software-based learning, where we are allowing our students to work on software, design something, create something. Then on a parallel hand, we also give them an opportunity to work on a creative end and be artistic, create something out of art, like paint something or maybe design something. Then we offer DIY kits, which is do-it-yourself kits to our students, which allows them to work technically on a particular project. Then experiment-based learning is really powerful. You give a very difficult or a complex scenario or a very new scenario to a student and try to understand what type of results can come out of that experiment. Then make them do the presentation out of whatever their learnings or failures were. Then research-based learning, reading, writing, all those things. Then it is in 21st century, it is really important. A lot of things we can get on internet for free, right? So we need to be aware of our student about how to use internet as a tool and get the correct set of information on these particular areas. Then next we talk about the contest-based learning. So whenever we put our students or learner into a contest or competition-based environment, this somehow, it's a human nature. They learn more fast, more quick, and more broad, right? So this is what we do. We expose them to contest-based learning as well in our labs. Then gamification. Kids love to play games, right? Like, to those of you who are parents, you know that how wonderful, how much time these young audience is spending on playing games, video games. So gamifying space learning is our vision. So that's what we want for for our participants who are in our laboratories working on various projects. Then the project-based learning is really important. So this was it from my end. Thank you very much, everyone. And keep supporting Liftoff Africa. We have planned many seminars and webinars like that. And let's hope we establish such lab facilities in Africa. Thank you very much.
The exploration of space will go ahead, and it is one of the great adventures of all time.